I've created a repository in GitHub. The repository is available under my GitHub account, which you can see here in the website. It's a Bunwas, and the repo is manning twitch build deploy API. First, I've included a README file in the repo with some information about myself and also brief agenda of this presentation. So about myself, my name is Jose. I'm a full stack consultant based in London, and I am the creator of Microservices.io. Microservices.io is a website. Yeah, basically you can mock an API with this tool, and this makes it easier for API client developers to build their clients against an API specification. There you go. This is what it looks like. So you would paste the specification here. Only works for REST APIs at the moment. You would paste the spec here. You click mock and you get your mock server. I'm also the author of Microservice APIs with Python. This is a book published by Manning. The link is here. The book is currently in MIP or Manning Early Access Program, which means the book is still in development, but we have released most of the chapters so far. So 8 chapters we've released so far, and we have written most of the rest of the chapters. So we will be publishing the remaining chapters of the coming weeks and months, and the full book is expected to be in print early next year. The book is about building microservices and also their integrations with web APIs in Python. If you want to get the book, there's a discount code that has been released specifically for this presentation. So the discount code is here. You can use it anytime. But if you buy the book today, the book is deal of the day, so you get a more beautiful discount if you want to get it today. Because the book is in production still, if you read the book and you find that something is missing or is incorrect or not clear, or you don't agree with something that I say, you can give me this feedback, and I can incorporate this feedback into the book. And I really appreciate this kind of comments. So if you want to say something, please feel free to reach out to me. Now, the presentation is titled Building and Deploying Reliable APIs with FastAPI. So FastAPI is an API development framework for Python, very popular at the moment. So we're going to build a simple API with FastAPI, and we are going to deploy the API to Heroku. We are going to set up also the continuous integration server with Travis, and the keyword here is reliable. So I'm going to show you a workflow that you can use to make sure that you deliver successful API integrations. And what do I mean by this is that when we build an API, we build it for other people to consume. So if you think of an API as a product, it's just a type of interface to service, and it's just like a website. It has an interface. All the people are going to consume this interface, and they expect the API. They need to have some expectations of how the API behaves, what it does, and what they can do with it, right? And our job as API developers is to deliver on these expectations and make sure that the API that we deliver complies with what our users are expecting. So I'm gonna show you one way to do this in this presentation. Briefly, the agenda, what I'm going to go through is, I just did the introduction. So the next step is I'm going to introduce the simple API that we're going to build in this exercise. Then we're going to build it with FastAPI. Then we are going to test it. And I'm going to show you one way of testing the API without you having to write a single test. And this is very useful because you won't have to spend any time writing validation tests for your API. There are tools and frameworks out there that can do this for you. They do it very well, probably much better than we could do if we were writing the tests ourselves. And it's going to help you speed up the development process and make sure that you don't take the wrong path. If you have some bugs in your API, all of these you're gonna catch it early on, and you're gonna be able to fix it. We're gonna set up a continuous integration server with Travis. and we're going to configure it to deploy to Heroku. So we have a lot of things to do, so let's get started. And I'm hoping we can finish within in less than an hour or so. This is the deal of the day in Manning. My book is listed here, but there are other books as well as part of the deal. All of them really interesting, so feel free to check this out, and if you're interested buying one of these books. So the API that we're going to build today, that's going to be a simple TODO API. The specification is available in the repository that I prepared for this presentation. It contains the basic files, no code yet. It contains a pip file with dependencies. It contains the README file that we went through before. It contains the OpenAPI specification for the API that we're going to build, and a package JSON with some libraries that I will comment later. This is a fresh repo. We're going to build the API on top of these files. So I'm going to show you with my development editor the API. The API is here. It's a very simple API for managing to-do items. Basically, it's going to allow us to create a task, to update or get the details of a task, and to delete the task. It's written in OpenAPI specification format version 3.0. The most recent version of OpenAPI is 3.1. If you can, you should be using that version. But this is an example that I have from a previous exercise, so just to avoid changing, it's using the previous version at the moment. Visualizing APIs in this kind of documents is not that easy. What I recommend is you get a proper visualizer. So I'm going to show you one here. It's Swagger. So there are different ways of visualizing REST APIs. Swagger is the classic. Is one of the most popular still. Usually when I want to get a picture of what an API looks like, I go to Swagger's editor. So that is in editor.swagger.io. By default, it comes with the Swagger pet store, which is the classic example for REST APIs. We can paste here our API specification for the TODO API that I showed you before, and this updates the Swagger UI. So here it's very easy to see what the API actually looks like. So it has two URL paths. One is generic TODO for the generic resources representing a TODO item. And then we have a specific resources targeting each specific task and what we can do with them. What happens here is, so each URL path offers a bunch of endpoints. The get endpoint on the TODO URL allows us to get a list of items. The post TODO endpoint allows us to create a task. The get TODO plus the task ID allows us to retrieve the details of a task. We can update the task with the put endpoint, and we can delete the task with the delete endpoint. Now, a couple of words here about put. Put is, so this is from the HTTP protocol. Put is not really an update method, it's a replacing method. So put is supposed to be idempotent. So when you hit the endpoint, regardless of how many times you do it, it's always going to give you the same response. And what we're supposed to do with a put endpoint is we are supposed to send to the server a full representation of the resource that we want to update, and the server has to replace the representation of the resource with the payload that we are sending in the request. If we wanted to be able to update the resource based on be able to update the specific properties of the resource, we would be using a patch endpoint. But to keep things simple in this presentation, I'm just using put. We can see also there are a bunch of validation schemas for the API. So there is an error schema, which is just generic for representing errors whenever something goes wrong with a request. There is also a create task schema, and this is the representation of a task that is required when we send a task to the server to create it or to update it. We also have get task schema, which is the schema that we can expect from the server when we get the details of a task. And we also have the list task schema, which is it tells us what the collection of tasks is going to look like when we hit the get to do endpoint. So, right, so this is about the API that we're going to build. It's very simple, but it contains all the ingredients that you're going to find usually when working with APIs. Now, let me introduce the tools that the frameworks libraries that we're going to use to build the API. So that is listed in the pip file. So we're going to be using in this specific exercise version 3.9 of Python, but really this will work with any version of Python upwards of 3.6. So if you want to use a different version of Python, that's fine. I'm not going to use any of the specific features of the latest releases. Then the cool packages of this application are FastAPI. That's the framework that we're going to use to build the API. It is Uvicon, which is the web execution framework that we're going to use to run the server. And then there are a couple of dev packages. One of them is called Dredd hooks, and I'll talk about this package a little bit later in more detail. When I talk about the test framework we're going to use to test and validate the API. The other one we have here is Data Model Code Generator. Now, this is a package that is going to allow us to generate the schemas from the API specification directly into code. So we don't have to write any code to implement that part of the API. And that's really neat and really useful. And it's also one of the parts where we tend to make more mistakes when working with APIs. So it's really useful to use one of these libraries to get this done. Let me introduce each of these libraries in a little bit more detail if you're not familiar with them. So FastAPI is really popular API development framework in the Python community right now. It's has the selling point of being highly performant. It's very fast and reliable. It's a little bit different from what we are used to with Flask and Django. And it is more performant, or it can be more performant for a couple of reasons. One of them is it's built on top of a Starlet. Starlet is mentioned here in the README. So Starlet is an asynchronous server implementation in Python. A big asynchronous has advantages in the context of web servers, because if you think about it, a web server is mostly all about I/O operations. So we have incoming requests over a socket, and we are responding to them. And typically we have also connections with the database. So when a request comes to the server, then at some point we fetch some data from the database, and during the time that we're fetching that data, there's an advantage in being asynchronous in that the execution framework, while a specific job is waiting for data to come from the database, can put that job to sleep and take care of all the tasks that require attention from the execution framework in the server. So that's how we gain a little bit. That's how we gain a little bit of speed with FastAPI. But also, it's faster because of Pedantic. Pedantic is a highly optimized data validation library for Python, and that's the part that helps us to validate and serialize data in the API. If you are not familiar with with Pedantic, it's really neat. You can use it for anything that requires data parsing, validation, and things like that, not just in the context of web servers, but also in the context of configuration parsing, data exchange across different components of a system, and things like that. It uses type hints to define the validation rules of our data, and it's very elegant, it's neat, and it's also, with the increasing use of type hints in Python, it feels more Pythonic than what you can find in more traditional frameworks to data validation. So that's a few words about Pedantic and FastAPI. We're not going to create our data validation models in Pedantic manually. We're going to use data codes. How was the name? data model code generator. So let me show you how we do that in the first place. What I have here is the fresh repo, as you can see it also in GitHub. First of all, let me create a folder to contain the code for the API. So that's because the API is to-do, as a to-do service, let's call the folder to-do. Within to-do, we're gonna have the files of the application. Now, I'm gonna keep it simple for this presentation, but typically what I would do is within to-do, I would create a folder which contains the web server API layer implementation, and in a different folder, I would have the core of the service implementation. And this is following the idea of hexagonal architecture. If you're not familiar with the concept, it's one of the best concepts of software development, like in terms of software architecture. So if you Google that, hexagonal architecture, you can read this article from Wikipedia to get familiar with it. I also talk about this concept in my book, and I show you how you can apply this concept to building your microservices. The basic idea is, like you can see in the image here, there's a core to the application logic that we implement, the service, right? That's the part of the code that implements the capabilities of our service. And then everything else, everything that like implies the code, talking to all the things external to the code, that comes in the form of ports and adapters. So if you think of interfaces, how we interface with the core application logic, so we can do that through a web API, but we can do it with other types of interfaces as well. Like it's listed here, we could have a CLI, we can have a UI, obviously we can have an API as well, and that would go, if I was building my service in that way, I would put it in a different folder with all the utilities and implementations that go with each of these layers, each of these interfaces. And then if we have part of the code that needs to talk to a database, we have another module or folder for that. And then we would have connectors to databases, to queues, streams, files, cache servers, and whatnot. And the idea of this is it helps us to implement, our application towards interfaces and to have less reliance on the specific implementation details of each of these layers that are connecting with the core of the application. Now we're not gonna do that here. Let's keep it simple. I'm just gonna have one folder for the API. It's gonna contain all the folders that we need to run the server. We're not gonna have databases or anything. We're gonna keep it simple. And but yeah, if you wanted to make it better, use something like hexagonal architecture to decouple your layers and your components. Now, first thing we want to do is to install the dependencies. We use pipenv for that. If you don't have pipenv installed, you can install it with pip. So it will be pip installs pipenv like this. I'm not going to do that now because I already have it. So I'm just going to install the dependencies. That you do it with pipenv install. Okay, actually I just realized I made a mistake because we have some dev dependencies like I showed before here in the pip file. We should be running it with the dev flag so that we get the dev dependencies installed. So let me do that again. Okay, so we have the dependencies. Now we activate the environment, and we do that with pipenv shell. That is the environment activated. We should have all the dependencies in place that we need. I don't think anything has changed here. The repository already contains a pipenv log file, so it's ensuring that if you install from this repository, you install the exact same dependencies that I'm running in this exercise. So, like I said, we're going to use a tool to generate the Pedantic model. So let's go ahead and do that. I think I ran this before. So the command is like this. data model code gen, we need to give to this command the input file that we want to use to generate the schemas. So that's basically the path to the API specification. And we need to give it the path to the file where we want to have the Pedantic models generated. So like I said, we're going to keep it simple in this case. So it's going to be just a schemas file under the to-do folder. So let's go ahead and run this. Okay, that was fast. Now that is available here in this file. Let me make this bigger so that you can see better. Okay. So this file contains a few details about how we generated the file. So it gives us the path to the file that we used to create these Pedantic models, and also the timestamp of when we ran the when we created this file. Data model code generator does a pretty good job at creating the Pedantic models from our API specification, but sometimes there are a couple of things that work a little bit different in Pedantic with regards to OpenAPI, and there are a couple of things which are going to change because of that. So if you see, we've got the error schema which we had in the API. That's good. We've got the create schema, create task schema as well, and we've got the get task schema and the list task schema. So all of that is good. The only thing we don't like so much is the duplicated code around here. So these are enumerations. So enumerations are properties of an object that take on a constrained number of values. In this case, we have enumerations for the priority task, the priority property of a task. We want to make sure that only represents one of these three values, low, medium, or high. And we also have an enumeration for the status property of the task. So it can only be pending, completed, or in progress. Now, in the OpenAPI specification file that is here, if we go to this schema, the enumeration is embedded in the definition of the schema. So we don't have an external object that represents the enumeration. Now, Pedantic doesn't do it that way. Pedantic has an external object, an independent object that represents the enumeration, and then it uses this enumeration in the definition of these properties. That's fine. The only problem is in this specific case, because the priority and the status properties are duplicated in two schemas, we are getting duplicated enumerations as well. So what we want to do is delete. We want to delete these classes. And we want to change the pointers here so that they point to the same classes here. And that makes sure, will ensure if we ever make some changes to these classes later in the future, the changes will apply both to create task and get task. So we don't have to duplicate any of our efforts. So that is the Pedantic models. We've got the models now. Now let's go ahead and start building the API itself. So first thing we're gonna do is we are going to create a server file. This file is going to contain an instance of the server, of the API itself. It's going to be the entry point to the API, and then we're going to create another file called TODO. It's going to be API.py, and API is going to contain our view functions. So we're going to implement the endpoints of the API in this file. Now. One thing I would like to say is I have two branches in this repo. So one of them is master and the other one is test. So I've been testing this before the presentation to make sure everything works fine. So the whole code implementation is in test at the moment. I will promote this to master later, and you will be able to see the implementation in master maybe tomorrow when I find the time to put it in master. Meanwhile, let's go back to master. Right, okay. So let's start creating the entry point for the app. That is going to be in the server file. Let me make it bigger so that you can see. And so to create the entry point, if you have experience with Flask, this is very FastAPI offers an interface which is similar to Flask. So what we are going to call here the server is the classic application object in the context of Flask, and this application or server object is going to give us decorators that we can use to create the endpoints of the API. So let's go ahead and import the FastAPI class. So from FastAPI, import FastAPI. And then to create an instance of the server, we simply need to say server equals FastAPI. Okay, so that's the instance of our server. That's the entry point into the API. And then this is the server object. This gives us the decorators that we can use to create the API views and all of that. But we have to load those views as well to make them available to the server when we start up the server. So for that, we can use different approaches. I'm going to use a simple approach here, which is importing directly the file. This is going to load the API module at load time. And it's going to make the API views. It's going to register the API views with the server object on a startup time, and that's going to do the job in this case. We're going to say we run the server in debug mode. Right. Missing a keyword here. Okay. Okay, so this is the entry point to the app. Now let's go ahead and start implementing the endpoints. So first thing, like I said before, I'm not going to use a database here. That would be it will make the presentation a little bit more complex and a little bit longer. So to keep it brief and simple, we're gonna store the items in an in-memory list. So that's gonna be todo equals a Python list. We're gonna put the items in this list. We're gonna delete them from this list, and it's just gonna work that way. If we're building something for production, we want to persist our data in a database or something similar. But we're gonna keep it simple in this case. And now let's start building the endpoints. So let's go ahead and do the simplest one, which is the get to do endpoint. So to do that, we're gonna use the get decorator on the server object. Let's import that. So that is the server variable. The first argument to the decorator, first one word in this method. This is directly the HTTP endpoint of the URL path. So FastAPI exposes, allows like every HTTP method through the object. So we're going to have get, post, put, patch, delete. Probably there is options as well. Any method that we need. Then the first argument for this method or function is the URL path where we want to register the method. The second important argument we want to give it here is the response model. So that is response model. That is the Pedantic class that FastAPI has to use to validate the data and to serialize it. So that is going to be list tasks schema, and let's import it. Right. So And as I said that, another clarification is, so when we have an API, we want to make sure that any data that is sent by a user is validated. That for sure we have to do. But there is also the possibility of validating data that we send to the user. And there are different approaches to this. Sometimes people prefer not to validate data. There are good arguments for both approaches. So if we don't validate the data, there is the assumption that any data which is sent by the server is supposed to be correct. My case, I prefer not to make many assumptions. So as much validation as we can have, I prefer to have it, because we could have some error in some field that has the wrong name in the database, or it gets the wrong translation in the API, in the application logic, and we want to make sure that this is validated before we get it to the user. Otherwise, we run into these problems of maybe not delivering to the expectations of the client of the API. So FastAPI is going to perform validation both sides, for data coming in and for data going out. Now, this is a decorator. We need to name the function that implements the get endpoint, and we're going to call it get tasks. We call it like that because this is really what it does. We are just sending the list of tasks, and what we're going to do is return a dictionary that represents the payload for this endpoint. So if we go back to Pedantic, well, not Pedantic, but the schemas file, we see list task schema has a task property which points to a list of tasks, and that's exactly what we do here in plural. And to do is holding the list of tasks. So here is gonna be, we're gonna store it as dictionaries, but FastAPI knows how to serialize those dictionaries into JSON objects to send them to the user. Now we already have an endpoint. At this point, we can run the server already and see what it's looking like. So let's go ahead and do that. So to run the server, like I said before, we're going to use uvcon, and to get it started, we do uvcon, and we need to give the path to the object that represents the server. So that is to do. Within to do folder, we have server file, and within the server file, we have the server variable, which represents the the server. Let's run this in reload mode, so that any changes we make to the files can be picked up by Unicorn and refreshed. So it picks up the changes to the files. So let's do it that way. Okay, so now the server is running on this address. Let's copy this and paste it in the let me hide this. We don't want to go that. We want to hide it. Well, it doesn't hide. Let me do it a different way. Doesn't go away. Okay, well. Anyways, that's the URL for our server. Now, the naked URL doesn't have. It's not something we have defined in the server. Typically, if this was a proper website, this would give you the UI. Perhaps we don't have such a thing. We're just building the API, so we don't have anything. If we hit the to-do endpoint. We did implement the get to do endpoint, so we get an empty list of tasks because we haven't created anything else at the moment. The interesting thing about FastAPI is it can also create a Swagger UI from the code. So if we go to the docs endpoint, we get a Swagger UI, and this allows us to interact with the API. So we can click here to try the method, we can execute, and this is talking to the server right now, and we're getting an empty list of tasks like we did before when we hit the endpoint directly in the URL. Right, so this is for one of the endpoints. Let's go ahead and implement the rest of the endpoints. I can see we are running a little bit late, so let's be agile here. So let's go with the post endpoint. This is also on the to-do URL. The response model is get task schema. And something else here that we want to do is, if you see the specification, post has 201 response status code, and we want to specify that here. So by default, FastAPI will send 200 responses to the client, but if we have a different type of response, we need to specify that here in the arguments to the decorator. So that's going to be status code, that is status HTTP 201 created, and that status comes from Starlet. Okay. Something here, HTTP 201 like that. Okay. Now let's give it a name to this method. We're gonna call it create task, and it's because this is a create method. It takes a payload. We capture the payload through the arguments of this function. So the payload we specify like this. We put a type hint pointing to the Pedantic model that validates the incoming payload. So that is create task schema. We need to import it as well. And what we are going to do is get the dictionary out of this object. This is going to be an instance of a Pedantic model. So we want to say payload dict. And we want to populate the task with any missing attributes that the user hasn't added. So if we go back to the specification here in create a schema, we see the only required property of this schema is task. The priority and the status are optional. So we're going to add those. We're going to add default values for those properties if well, actually, they already come with default values. We're going to just going to capture them from the payload, because Pedantic is adding the default values. If we see in the definition, these properties are getting default values, so the object is going to come with those values already. So we don't need to do anything. We don't need to do that here. The only thing we need to add is the created property and the ID property. Those things need to be created in the server. So let's go ahead and do that. That is a UID. We're also going to do the created field, and that's a date time. So date time now. Now, to have a string representation of the enumerations, we need to capture the value of the enumeration. So that is in the task status value, and then task priority is the task priority value. Then we add this to the in-memory list of tasks. So we add the task here, and then we return the dictionary representation of the task with the properties that were added in the server. So the ID and the created property are set in the server. Everything else is coming from the user, and or is added by Pedantic by inspecting the schemas and figuring out which attributes have default values if they haven't been set by the user. little bit quickly to make sure I don't hold you here too long. I'm gonna just copy paste the get to do with the task ID endpoint. We need to import this as well. Not like that. Well, yeah, that's fine. Now, one thing here, for those endpoints which are trying to retrieve a specific item, it's possible that the item requested by the user doesn't exist, and in that case, we have to respond with a 404 response, saying that the item doesn't exist or couldn't be found. So to do that, we do it by raising an exception like this, specifying the status code of the exception and the error message passed as the detail of the exception. So that again is part of the API specification here. So in the put endpoint, for example, has 404 response here if the item is not found. Let me put here quickly the implementation for the put endpoint. This again is complaining, and let me do the one for delete. So the status code again is different. Here is going to be a 204. So that is status HTTP 204. We're going to leave it like this for now, and this is delete task. We get the task ID. We capture it from the URL. The type of this is a UID, so we put it like that. And what we do is we say for index task, we iterate the to-do list, and we say if task ID is equal to the task ID given by the user, then to-do pop, we're going to delete the task by the index, okay? And then we'll return. So 204 is an empty, gives you empty responses. This is from the HTTP protocol. It's not expected to return any kind of payload, so we just return empty. This is by default is none, but we're expecting the framework to translate this into an empty payload. And then if it isn't found, we raise the same exception that we are doing with the other endpoints. So that goes here. Okay. Now we can test it. So we were running this with reloading enabled, so all the changes will be reflected in the API if we reload this. So these are all of the endpoints. If we try the post endpoint and we create a task, that is fine. If we get the list of tasks now, we get now one task. We can also validate this like we did before, directly with the talking directly to the API. So this should be 8,000 to do, and it's loading. But here we have the task that was created before. So that's beautiful. Now, we build the API. Now we have to test it. We want to make sure that it's behaving properly. It's delivering on the promise of the specification. So let's see one way of doing that. The way I'm going to do it is by using a API test framework called Dredd. So Dredd, as in Judge Dredd, is a classic API test framework. There are some others these days, which I encourage you to explore, especially schemathesis, which is it's written in Python. It's really neat. I'm gonna focus on this one because it's the classic, and it does the job, and it's what I've been using for a while now. But perhaps it's worth doing another video later showing how schemathesis works. So we're going to use this library. It's an npm package, so that's the reason why we have an nph package in this repo. It is listing Dredd together with another dependency, which we're not going to use here. So let's go ahead and install this. Actually, I installed things with yarn before, so the only thing you need to do to install things here is run yarn. Right, something went wrong. Right, so this is an error that you can run into. If you're installing npm dependencies, you need to ensure that you have the correct version of Node. Now, to manage Node versions, normally we use nvm, and you can list which versions of Node you have in your system by running this command. In my case, I have a more modern version of Node, so I'm gonna go and use that one. And now we can run yarn again, and I already had the dependencies installed. I was ready for this because otherwise it takes a while. Otherwise it would just install the dependencies. Now we have Dredd installed. Let's run Dredd to test the API. To make sure it's tested, we need to run the server. So in a different tab here, I'm going to execute the server. So let me activate the environment and run uvcon. That is TODO server reload again. So that is running, and then so obviously npm dependencies will give us a node modules folder. Everything's going to be within node modules, everything we need for about npm. So the Dredd command is inside of that folder. So let's go ahead and run node modules.bin.dredd. And then what we need to give it is first is the API specification against which the API has to be validated. So that is our OpenAPI specification file. After that, we need to give it the address of the server where the API is running. So that is HTTP localhost on port 8000, just like that. And we have to give it the command that it has to run to be able to launch the server. And actually, I don't need this running. So that is going to be uvcon, and that's TODO server. Okay. So we run that, and so Dredd is starting the server. It's looking at the API specification. It's looking at the endpoints, and it's going to trigger requests to the endpoints to ensure that they comply with the schemas declared in the spec. So it's working slowly, but it's working. By the way, you can ignore all of these warnings. The specification has been validated with Swagger's editor, which means it's correct. So don't worry about this. Again, at some point it will finish. Okay. Oh, not connecting to the server. So, oh, that's why the address is wrong here, missing a 7. Okay, let me stop the server. Yeah, it's supposed to start the server itself. So let's run this again. Should work. Okay, beautiful. Okay, now it's working. Everything is passing except three tests. If you look in detail at the details of the output of the test, the 3 endpoints which are failing are the endpoints which target the specific items of the API. So the to-do/to-do task ID, and they're failing because Dredd is trying to request the details of a specific task, and that task doesn't exist. So we have to find a way to tell Dredd to create a task and hold that ID in memory and reuse the ID when it performs actions on the task. To do that, we're going to use Dredd hooks. And that's where the other dependency that I mentioned at the beginning comes in. So it's this one here, Dredd hooks. So this allows us to create, to customize the behavior of Dredd and ensure it does things in the way it should. So let's go ahead and create a hooks file. And because we don't have much time, I'm just gonna paste the content of the file, which I already have written. So that is hooks. Let me make it bigger. Okay. Let me explain to you what happens here. Dredd gives us some decorators to customize what happens before or after we launch a request to each of the endpoints. So what we want to do, thinking through this, is we want to make sure that when Dredd launches a request to the post to do endpoint and it creates a task, we want to make sure that Dredd captures the ID of this task and it reuses this ID in each of the requests that address a specific task. So to do that, we're going to use the after hook, which is after request, on the post to do endpoint. To reach this specific endpoint, Dredd uses a specific type of notation where we have to say the URL path that we want to use. Within this URL path, the endpoint which corresponds to this description, create a task. So if we go to the OpenAPI specification and we look at post is the endpoint which has a summary that has this description. That's how you do it in Dredd. And then within this endpoint, we want to look at the 201 response because obviously this has more responses. I'm keeping it simple here, but this can have, it's going to have also 500, 502, any kind of response which should be part of the API. But I'm showing only the successful response in this case. So for the 201 response, look at the object that represents the response in JSON for this endpoint, because obviously 201 can have responses in the content can come in different formats. It can come in JSON, could be coming in XML or some other formats. We are only using JSON in this API, but nothing prevents you from using other types of serialization formats. So, so we are customizing the behavior after the post endpoint and customizing the behavior before each of the to-do specific item endpoints. And what we're telling Dredd to do is we have a global dictionary here. This is where we are storing the ID of the created task, and we're telling Dredd to use this ID to form the URL for each of these endpoints. Okay, so that's basically what it does. Let's run the tests again using this hook file. So the command is like this, same as before. The OpenAPI specification file, the address of the server, the command necessary to run the server, and in addition to that, now we are using the path to the hook files and the language in which the hook files is written. So let's go ahead and run this. And everything passes now. There are some warnings before. There's a warning here actually which is relevant to us. And if we see here is related to the delete endpoint. So it's Dredd is not failing here, but it should at least give us a more clear warning, because it's a little bit easy to miss here and say, okay, everything's passing. There's an implementation detail that we didn't do correctly in the API, and it's here in the implementation. What we do is we return an empty response, but that's not sufficient to get an empty response with FastAPI. We also have to specify a different type of response model. I think it is response. Let me look at the not here. It is the response class. Sorry, so response class should be just the response class from Starlet. So this one. Otherwise, FastAPI may use by default the JSON JSON serialization response, which is going to at least give us a string for this empty response, and that's not really accurate. It's not what we should be doing, and that's why we have this warning here. So let's go ahead and run the test now. And now we don't have that kind of warning. So everything is passing beautiful now. It's tested. It's the API is delivering on the promise of the specification. So let's go ahead and include this test in a CI file as well. So we're going to create a Travis file. Travis YAML like that. And we're going to configure it to run the job. So a little bit short of time. So let me just copy the file directly from what I have before. Let me make it bigger. And let me tell you what we have here. So we're telling Travis to use a Python runtime to build and validate the app. We're telling it that the version of Python should be 3.9. But because we have an npm package, that's Dredd, which is running the test, we are telling Travis that we also have a Node.js dependency, and the minimum version of Node.js that we need is that one. We're just pinning Node.js to that version. Then before installing or before setting up the test environment, we are telling Dredd to install Dredd and to install the Python the dependencies for the Python application. Then the script is the test script for the app. So we are telling we're just giving Travis the exact command that we need to run to test the application. This is what we've been doing before in the terminal. And then we have some deployment configuration. So we want, like I said, we're going to deploy to Heroku. I've created a Heroku app for this before, so we're going to see how it deploys. The only thing I need to update is the deployment key. So this is encrypted by Travis, and it's encrypted for this repository. If you take this key out of this repository, it won't work somewhere else. Let me show you how we create that key. So that is Travis. Like this. So you need to install the Travis CLI and you need to install the Heroku CLI. Okay. So we're gonna use Heroku auth token to generate the token. I'm not gonna run that here because it will expose my my real token. But what I can do is run it with Travis with encrypt flag, which is going to encrypt the output of this command. And then I'm telling Travis to add the output of this command, the encrypted output, as the deploy configuration, as the key for the deployment configuration of this application. I'm also telling Travis to use the travis.com. Travis.org was deprecated a while ago, so you are only able to use the CLI with this flag anyways. So let's go ahead and do that. Okay, yes, we want to overwrite the file, and now we have everything we need. So let's add all of this into GitHub. Let me see in which branch we are. Let me check out into different branch. Let's say running Twitch. oops, we need to say like this. We're creating a new branch. So we are adding the files that we just created during this session. So the Travis file, the hooks file, and the files that implement the API. So let's go ahead and commit this. And now we're in this branch. So git push origin like that. Okay, so that is uploading the branch into GitHub. So if we refresh this, we can now create a pull request to merge this into master. So let's go ahead and create it. Okay, and in the meantime, Travis is running the test. So let's go ahead and check out Travis, which I have it here. Okay, so this is running. Let's tail the logs so that we don't have to do it manually. And Travis is now setting up the test environment. And within soon it will be running the test. So setting up the server, installing Python. So it just cloned the repo. It's installing the dependencies, ppend and npm. Let me make this bigger so that you can follow better. Oops, not like that. So running the test now, and everything's passing. That's beautiful. If we had made any mistakes in a code change later on, this will be captured by Travis and it will report to us if we forgot to run the test locally, for example. So the tests are passing. GitHub is updated with this. We have this tick of the successful checks. So let's go ahead and merge this. When we merge this, Travis is going to validate again. It's going to run the test suite against master. And if it passes, it's going to deploy to Heroku. So let's go ahead and do that. Okay, let's delete the branch and check out Travis. And so here it's the job is queued. We'll start in a moment. Starting the machine. Okay, let's tail the logs like before. It's setting up the server, cloning the repo, installing dependencies. Running the test now, and already done. Everything passes, and deploying. So that's already deploying to Heroku. So I created an app here. I call it Manning Twitch, and it's just hooked with Travis, so that we can monitor the deployment process here. Again, we're installing dependencies, setting up the app, compressing, and right, that's done. Okay, and that's already released. It's released version 5 because, like I said, I was testing before to make sure everything was working for this presentation. So let's go ahead and visit this URL here. That is, oh, something went wrong. Oh, actually, I forgot to add the proc file. So if you're deploying to Heroku, you need to have this file that runs the app. So let me do nano here, and let me find the content of this file. It should be like this. So we are specifying a web job in Heroku. We are telling Heroku that the command to run the web server is like this. We are telling it to listen on all IPs, and we are telling UVCon to pick up whichever port Heroku is using to listen to. So that is done. Let me add port file. Let me commit that. And to save some time, let me push directly to master. So let git push twitch master. Oops, forgot origin. Doesn't allow me, so I need to check out into master first. Git pull origin master. And I check out back into the branch. Then I rebase master, and then I should be able to push again. So like that. Okay, that's done. Now we should. So Travis is going to run the process again, and it should be able to deploy successfully. And if I haven't forgotten anything, the app will be running Heroku in a minute, couple of minutes. So let's give it some time. Here it is. Let's follow the logs. All right. So setting up the system, you know the story. By the way, it's possible to optimize this process. You can have a cache in Travis and check if the dependencies haven't changed. If the dependencies haven't changed, don't install anything. Just reuse the build or the dependencies from the previous build. Well, I'm not doing that in this case, just to keep it simple, and also because we don't have many dependencies. But in some cases, it can be painful to having to do everything every time. So it's testing. The test should pass because we haven't changed anything. And it's deploying now. So coming back to Heroku, we have another build. Okay, so it's compressing the app. It's already built, and it will be releasing soon. Okay, that's already launched. So let's check out the URL again. It's loading. It's not cached yet. It has to load the app, set up a container, things like that. We don't have this URL path, obviously, like before, but we can check the to-do endpoint, and it's giving us an empty list. That's working beautiful. Let's check out the docs, the Swagger UI, and let's use it to create a couple of tasks from here. So let's execute this a few times. We created a bunch of tasks. If we run this now, we will see the task with a caveat. Let's run this and see what happens. Okay, we got a task. If we run it again, one, it's always giving us the same. Now it gives us 3. What's happening here is Heroku launches a few containers to handle the requests. Because we have an in-memory list of items, each container has its own list. So it's perfectly possible to create a bunch of tasks and you hit this endpoint and you get an empty list. That's because it's just hitting another pod or container running the app. If it was a database, we wouldn't have this problem. We would be getting the as many tasks as we create. So sorry. So that's it really. We had a look at an API specification. We built it. We tested. We set up the continuous integration server for it. We deployed to Heroku, and we are interacting with it. We've seen it works as intended. Now let me open Twitch now in another window. I'm gonna see if you have any questions for me. Running publications here. Okay. Right. The chat room is empty, which wasn't before. So I just texted. If you have any questions, maybe drop your comments now. I can't see anything from before. So if you want to ask something or give me some feedback, you can do it now. At least maybe say something. I know that you're alive. And I will close this in a few minutes. So let's. Like I said before, the application is, everything is available in this repository. You can check everything here. If all the code is now here because we just merged it. If something isn't clear here yeah, during my presentation, or something was confusing, or if there is something that you wanted to see but I didn't do, let me know. I can, so any clarifications I can do them later. If you reach out to me, and if there is something that I haven't done and you were expecting, I can do another video later. You can reach out to me in LinkedIn or in Twitter. I will put the links in the written file after this presentation. My Twitter handle is available here in my account. So if you want to text me directly in Twitter, this is my account. And I will include also the LinkedIn here if you want to connect with me. I hope some of it was useful, and I hope you had some fun with this exercise. I definitely did. And yeah, thank you so much for making time for this, attending the presentation. Again, I hope you had a good time, and connect or reach out to me if you have any questions or comments later. I would love to hear from you. Right, I'm gonna stop streaming now. I think that's what I'm supposed to do. I haven't done Twitch before, so I hope everything went fine, and the streaming will stop now.